Yeah, hello, good evening everyone. So let's start today's lecture. So today we are going to solve a week 10 assignment. So there are some questions regarding this week. So I hope you have completed the lectures from this week. And if you are new here, so let me introduce first. So I am Ravi Kumar, a PMRF research scholar at IIT Bombay, and I am taking assignments of Physics of Renewable Energy Systems, which is taught by Professor Amrish Chandra from Department of Physics, IIT Kharagpur. So let's start our week 10 assignment. So this is the first question. It says, for a quantum wire, the density of state can be expressed as. So these are the options. You just need to tell me the expression for density of state for a quantum wire. First, you need to understand what is the density of states. So, density of state is denoted by dE and it is a function of energy. As shown here, D is the density of state and it is represented as a function of energy. And this is a density of states, means number of states per unit volume. So in a volume of dE, total number of states will be density of state multiplied by the volume. So for a quantum wire, here we can see from the lecture only, quantum wire is a 1D structure and the density of state is expressed as given here. So this matches with option C. Yes, then option C is the correct answer. which is representing the density of state for a quantum wire. Let's move to the second question. It says the quantum well. So which of the following type of confinement? So it is saying quantum well. You must understand quantum well is this kind of structure. So it is 1D, 2D, 3D or what? You just need to tell me the same. These are the options: 1D, 2D, 3D or none of these. See, this is a bulk and this is a well. If we are cutting this bulk as this kind, so it is making, we are making it a well. And if we are suppressing it further, then we are making a wire. And if we are suppressing further, then we are making a quantum dots. So this question is asking about this well. Quantum well. So here also nanostructure material, quantum dots 0D, quantum wire 1D, and quantum well is 2D structure. So answer here will be 2D. Yes, answer is 2D for this quantum well. Let's move to the next question, which says in Ostwald ripening process the nucleation proceeds. This is a particular kind of process, Ostwald ripening process. So these are the options. For a long time, bring smaller and larger nuclei to coexist. Yes, it does. What it does, it brings smaller and larger nuclei coexist, means they are existing at the same time. Large particles tend to grow at the expense of smaller one, right? Because they are, you can understand, the smaller one are decreasing, the bigger one is increasing. The concentration of solutes and temperature of the solution strongly affect the growth. Yes, concentration and temperature, it always does. So it affects the growth. Absolutely right. And the last option says surface energy dominates over volume energy. No, it should be otherwise. Volume energy dominates over surface energy. So this is wrong. So answer here will be A, B and C. Now let's move to the next question, which says growth of nanorod can be commonly achieved by. It is saying growth of nanorod by colloidal process, by template assisted process, molecular beam epitaxy, atomic layer deposition. It is saying nanorod. Here you can understand, if we use a template or template assisted process, then these are the templates and carbon is filled in the spaces between them, and after dissolution of the template we got nano wires or nano rods. So here template assisted process will be the easier one. Our answer will be B. Let's move to the next question, which says what are the limitations of 2D structures? So these are the options: low surface area, difficulty in larger scale fabrication, difficulty in synthesizing defect-free structure, or limited number of surface active sites. You just need to tell me the limitation of 2D structure. See, these are the given advantages and disadvantages of 2D structure. So first says low surface area. So first is wrong because it is having large surface area. Difficulty in large scale fabrication. Yes, it is a disadvantage. So yes. Difficulty in synthesizing defect free structure. Yes. Limited number of surface active site. No, because it is given large number of sites. So B and C will be the answer. Yes, B and C are the answer for this question. Now let's move to the next question, which says the rate constant of a reaction with the activation energy is related by. These are the options. So you just need to tell me the correct expression which is relating K, means rate constant of a reaction, and activation energy EA. You must know the Arrhenius relation. So here the question is just asking the Arrhenius relation. So this is the Arrhenius relation we have. Here this K is the rate constant, is the basic logarithm, A is the pre-exponential factor, and EA is the activation energy, T is the temperature, and R is the gas constant. So it resembles with this. So option A is the correct answer. So it was just asking the Arrhenius relation, nothing else. So option A is the correct answer here. Let's move to the next question, which says the activation energy of a chemical reaction is 100 kilojoule per mole and its pre-exponential factor is 10. It should be like maybe. You need to find the rate constant K of this equation at a temperature of 300 Kelvin T. These are the options. It is very simple. You just need to solve it. Okay, let's see. So this is the given information we have. We have activation energy as 100 kilojoule per mole. So in case of a joule, we can write it as 100 into 10 to the power 3 joule per mole. Similarly, A is the pre-exponential factor, which is given by 10 millimole per second. And ln A will be 2.30 approx. Accurately, we can write 2.302585. So we are taking just 2.3. And T is the 300 Kelvin. Now you need to find the rate constant. So first you need to write the relation between rate constant and activation energy, that is known as Arrhenius relation. So if we write this Arrhenius relation like this, and we need to find this K. EA is already here. This is the EA. EA is here. T is here. R, we already know the gas constant. A is already here. After putting this value, we got this equation. And after solving this, like let me solve. It is coming, yeah, approximately we are writing this accurately, it is 40.493015. And after solving this, we are getting ln K equals to 37.8. And if we just Find the value of K here. It is coming 3.841 10 to the minus 17, and this is the unit of A. So here option C is the correct answer. Yes, option C is the correct answer. It is the rate constant which we need to find out from this question based on the data given. Let's move to the next question, which says choose the correct favorable properties of carbon based material. You just need to choose the favorable properties of carbon based materials. These are the options. Does carbon surface properties have large surface area? Are they expensive? Their pore volume is low or high, or their chemical or thermally stable or not? Yes. Large surface area? Yes. High cost? No, they are low cost. Small pore volume? Large pore volume? No. Chemical and thermally stable? Yes. So option A is the correct and option D is the correct. So option A and D are the correct answer for this question. Let's move to the next question, which says identify X and Y from the given graph. So first understand what is the graph is. So this is the potential energy axis, this is the reaction coordinate, and these are the reactants and these are the products. So they are going into the intermediate state and coming back to the product state. These are the options. So you just need to tell me which path is related to catalyst path or without catalyst path. So first tell me the activation energy will increase or will decrease with catalyst. This is the main question. If with catalyst the reaction rate is increasing or it is becoming better, it means our reactants are going through an intermediate state as low energy potential, and this potential and this potential, this one is the low potential. So this Y should associated with catalyst and this X should associated with without catalyst. So X without catalyst, B or Y with catalyst. So answer here will be A and B. Let's move to the next question, which says how to increase the activity of a catalyst. So there are some ways by which an activity of the catalyst can be increased. So these are the options: by increasing surface area, by increasing porosity, by increasing active sites, or all of the above. First understand how a catalyst works. So if this is a catalyst, what it will do, it will absorb reactant on its surface, and with the help of this surface they will react and convert into the product. So if large surface area, then more number of reactant will come. Yes. So by increasing the surface area, we can increase the activity. By increasing the porosity, if these are the two pores, if there are multiple pores, so then the reactants, number of reactant atoms or molecules will be binding more. So if number of reactants adsorbing on the surface of catalyst is more, then the rate of reaction will increase, because at the same time number of product molecules will increase. So yes, by increasing the porosity, we can increase the activity of catalyst. By increasing the active sites, yes, active site means these are the sites which are binding with the reactants. So all of the above. So answer for this question will be all of the above. So we are done with today's tutorial. I am going to upload this video on YouTube, which is dedicated to this NPTEL lectures only. You can watch the video later and ask question in the comment if you have any. So I'm ending this lecture. Have a nice day. Take care. Bye bye.